This is section 6.1, page 5, the last page. So we've got a definition and a few theorems to talk about. It says the distance from the center of a circle to a chord. So let's try this. The distance from the center of a circle to a chord. Okay, so let's draw in that chord. All right. Is the length of the perpendicular segment joining the center to the chord. So we want to draw a perpendicular segment. Okay, so it's perpendicular like that. Okay, so here it is. This is what we're talking about. That right there. Okay, that is, that's the distance that they're talking about, whatever that length is. Okay, so in the next theorem, it says chords that are the same distance from the center of a circle are congruent. So let's go ahead and draw a picture of this. Let's put the center of the circle in, okay? And then let's draw some chords, okay? And you want to draw them so that there's the same distance, okay? And I can see I didn't really put this in the center. We're going to say it is, though. Okay, so how do we do this? Chords that are the same distance from the center are congruent. So we're going to go ahead and draw in perpendicular to this one. Ooh, I'm over a little bit too far there, like that. Okay, so here, when you do this, perpendicular here, perpendicular here. Okay, so it's saying chords that are the same distance. So these two distances are the same here, okay? Let's call this P for the center, okay? Then we'll call this chord A, and this one B here, and this one C, and this one D, okay? And then this point here, we're going to call that M, and this point here, we're going to call N. So now we can write out a statement. If this distance, MP, so I don't want to bar over it because I'm talking about the distance, is equal to this distance, Pn. Okay, that's the same, the chords are the same distance from the center. Then, what does it say? Then, the chords are congruent. So AB, that chord, is congruent to CD. Hopefully that makes sense. If you separate them far enough, then they're going to have to be the same length. Okay, theorem 6.1.8. What does this one say? It's saying the converse of this. It's saying if you have congruent chords, so you start off with chords that are the same length, then they have to be the same distance away. So let's, instead of drawing that picture all over again, let's use the picture from above. Use the picture above. But we want to reverse it. This time we want to say, if the chords are congruent, so if we're going to say AB is congruent to CD, then what are we going to be able to say? Then those distances have to be the same. MP is equal to PN. Okay? All right. Theorem 6.1.9 says an angle inscribed in a semicircle is a right angle. All right, well, let's think about this. Here we are, an inscribed angle, which means that the vertex is on the circle, okay? So remember how we can calculate the formula. We know that it's equal to, when we're inscribed, it's equal to 1/2 the measure of the intercepted arc. So let's say 1/2, this is equal to 1/2 the measure of the intercepted arc. And I can just write RT here because if I wanted this one, I'd put an S in there. So say that. Okay? So what is that equal to? Well, because this is a diameter, okay, it's a semicircle, so that's the diameter. Don't we know that this has to be 180? Because it's the diameter, it cuts the circle in half. Okay, 180. Since RT is a diameter and cuts circle in half. Okay, so we can say it's 1/2 the measure of that arc, which is 180 degrees. And what is 1/2 of 180? 90. So we're saying the measure of RST is equal to 90 degrees, which is exactly what they said. If it's equal to 90 degrees, then that means angle RST is a right angle. Okay, so that's actually a proof of it. We just proved it. Okay, one more problem in this section. If two inscribed angles, so here we have X, W, Y, vertex is on the circle, so that makes it inscribed, and X, Z, Y. Again, vertex is on the circle, so it makes it an inscribed angle. If they intercept the same arc, notice they do, they both intercept arc XY, then these angles are congruent. Okay, well, let's see. Let's find out the formula. So if we're talking about measure of XWY, XWY, since it's inscribed, we say it's 1/2 the measure of the intercepted arc, which is XY. Okay, let's figure out what XZY is. Well, it's also an inscribed angle, so it's equal to 1/2 the measure of its intercepted arcs, which is also XY. Okay, well, if these are the same, if they equal the same thing, then they have to equal each other. So these are the same. So measure of angle XWY has to equal the measure of angle XZY, or the angles are congruent. Angle XWY is congruent to angle, XZY. Okay, so I want to write here that these, in this case, these are, move it over here, these are inscribed angles, and that's why that's true. Okay, that concludes section 6.1.